Hi, in this video we're going to explore the relationship between lattice multiplication and partial products. So I hope you've already watched the video on how to do 23 times 16 using partial products. But just to quickly review, if I want to multiply 23 times 16, both of those numbers are pretty large and difficult to multiply. So the first step is to break those numbers up into numbers that are easier to multiply. So 23 can be broken up into 20 plus 3. 16 can be broken up into 10 plus 6. And each of these four individual parts are much easier to multiply than either of these two large numbers. Let's review how we could then multiply these four parts. It helps to think of this multiplication problem as an area problem, where we have a rectangle that is 23 units long and 16 units wide. Now I can take my 23 units and break it up into 20 plus 3. And I can take my 16 units of width and break that up into 10 plus 6. Now I have four rectangles that I need to find the area of. These are my four partial products. In this first rectangle, I have a rectangle that is 20 units long and 10 units wide, so that's 200 square units inside. In this rectangle, I have 3 units long, 10 units wide, so that's 30 square units inside. In this little rectangle here, I have 3 units long, 6 units wide, so that's 18. And in my last rectangle, it is 20 units long and 6 units wide. 20 times 6 is an extended base fact. 2 times 6 is 12. And I add 1 0 to account for the fact that it was 20, not 2. So here are my four partial products, and if I want to find the answer, I just take the numbers 200, 120, 30, and 18, and I add them all up. I will get 8, 6, 3, 368 as my final answer. When I draw the lattice for a 2 by 2 problem, I need a grid that has 2 spaces on the top and 2 spaces going down. And I write my number going across. Now, I don't have to write 20 and 3 as I did here. I just write the number 23, and this is like the tens column, so this 2 really means 20. And I do the same thing for the 16. Again, I don't have to write 10 and 6 as I did here because this row is for the tens place, and so this 1 automatically means 10, and this number together means 16. Now the one thing that's different about the lattice than this kind of partial products multiplication is the lattice has these diagonal lines. The diagonal lines are great because they automatically help us to keep the place value straight. So notice that the multiplication for lattice is going to be pretty much the same. Let's start in this corner because it's the easiest to see here. In this box, 3 times 6 is 18. Here, in this box, I multiply the 3 times the 6 and I get 18. The only difference is that I write the 18 with the tens on the top side and the 8 down below. Now, here in this box, 3 times 10 is 30. In the lattice, I have 3 times 1, which is just 3, and the 3 goes down below, because if I wrote it on top, that would be 30. I can put a 0 here to hold the place. Now, you might say, well, how come it's 30 up here and 3 down here? Well, there's something very interesting going on here with these diagonals. It turns out that in the lattice, this first diagonal is the ones diagonal, and this second diagonal is the tens diagonal. So this 3 is actually in the tens place, so it is in fact 30. Let's continue multiplying. 2 times 6 is 12. Now this 12 has a 2 in the tens diagonal and a 1 in the hundreds diagonal. So this if you have 100 and 2 tens, there's your 120. My last multiplication problem is 2 times 1, which is 2. And although it looks like a 2, if we look up, we see that this 2 is in the hundreds diagonal, so if I have 2 hundreds, there is my 2 hundreds. Now remember, just like in partial products, to find the answer in lattice, you have to add. And instead of adding down columns, we now add down diagonals. So 8, 3 plus 1 is 4, plus 2 is 6. Notice that we also here have a 3, a 1, and a 2. The same numbers in this diagonal match the numbers in this column. And in the hundreds column, I have 2 plus 1, which is 3, just like I had a 2 plus 1 in this hundreds column. I will get the same answer if I read my answer around the corner. I get 368 when I use the lattice, just as I did when I did the problem with partial products. So although this might not all make sense the first time through, I would really encourage you to pick 2-digit numbers times 2-digit numbers and multiply them, both using a grid to help you do partial products and using the lattice, and see if you can see a connection between the numbers here and the numbers in this grid, and then see if you can see a connection between the numbers in the diagonals and the numbers in your columns as you add to find your final answer. And in all cases, you should definitely get the same answer whether you do the problem with partial products or with the lattice.